Okay, so in the last video we looked at a bunch of different functions: squared function, square root function, absolute value function, cubing function, cube root function. Here we want to look about parabolas, and parabolas have some very nice properties. Here is a parabola, as you look at it, and what are the kinds of properties that parabolas actually have? Well, they have a vertex, right? That's the bottom point, or the top point if it's a parabola that's opening down, and this vertex is at x equals 2, y equals minus 1. And so we write that as a point. The point is at x equals 2 minus 1. So, once you know the vertex, you can find what's called the central axis. A parabola is symmetrical about its central axis, right? So a point that's 2 units over on the left will have a point that's also 2 units over on the right. And the central axis here is given by the equation x equals 2. Right? The central axis always goes through the vertex. And since it's a vertical line, it's x equals something. So it's x is the x-coordinate of the vertex. What we can also tell once we know the vertex is that the range is y greater than or equal to minus 1. Greater than or equal because this is a function that is opening upwards. Right? And the vertex in this case is at the bottom of the function. Right? So any y value that's greater than minus 1, if we draw on a horizontal line, that'll hit the graph somewhere. If we take any y value from a point that's below the vertex and we draw that horizontal line, then that won't hit the graph at all, and so that's not in the range. So the range is y greater than or equal to minus 1. This point here, right, that's the y-intercept. We can actually read that off of the graph because it actually goes through at y equals 7, but you can't always read off the y-intercept from the graph. If you look at these two, those are my x-intercepts. I can't read them off from the graph. I don't know exactly what they are. But this is the kind of stuff that we want to know about a parabola, right? We want to know where the vertex is, and from the vertex you can find the central axis and the range. You want to know where the y-intercept is, and you want to find the x-intercepts. There can be 2 of them, there can be 1 of them, there can be 0 of them. But to find the x-intercept, you have to find an equation of the graph. And we can actually do that here by just looking at this. Right? The vertex should be at 0, 0, but it's been moved 2 right and down 1. So my graph is 2 right, down 1. Is it scaled? Well, if you go 1 unit to the right, you'd have to go up 2 units to get to back onto the graph. 1 unit to the left, 2 units up. So it is scaled by 2. It's not flipped at all. And so that's all we need to know. The equation must be y equals 2 x minus 2 quantity squared minus 1. Right? This 2 is because it's been scaled by 2. This 2, this minus 2, is because it went 2 right, and the minus 1 is because it went down 1. So how do you find the y-intercept? X-intercepts? Well, it's the same thing in dealing with lines. Set y equal to 0. Solve for x. So 0 equals 2, x minus 2 squared minus 1. This is actually pretty easy to solve because the x is inside of the squared, right? And so that's not, we can use the square root property. Let's move this minus 1 over to the other side. 1 equals 2, x minus 2 squared. Divide by 2. And now we can take a square root. And of course, when we take a square root, we pick up a plus or minus sign. And then add the 2 to both sides. Oops. So there's my x-intercepts. 1 is this one. That's 2 minus 1 over root 2. And the other one is this one. 2 plus 1 over root 2. And note, like we said before, the graph of the parabola is symmetric about the central axis. So if you go 1 over root 2 to the right to get to one root, then you have to go 1 over root 2 to the left to get to the other root. So 2 minus 1 over root 2 on one side, oops, on this side, and 2 plus 1 over root 2 on the other side. Great, and so that's everything we need to know. We know the intercepts, we know the y-intercepts, that's 7, and note, to find the y-intercept, you just set x equal to 0. If we set x equal to 0, we get 4 times 2, and that's 8, minus 1, that gives us a y-intercept of 7. We know the vertex, the central axis, and the range. And that's the stuff we want to know about parabolas. So we want to find the vertex, central axis, range, x and y intercepts. And we also want a formula and a graph. We want to know what it looks like, and we want to know what the formula is as well. So, flip side of this, here we started with a picture. So once we had the picture, we can figure out all the stuff we want to know and the formula. The flip side of that, of course, is suppose you have the formula. Let's say we have y equals minus 3x plus 1 quantity squared plus 4. We want to know all this stuff. Right? So, how can we do that just from this? Well, one easy way to do it is start by graphing it. Right? Write 1 flipped, rescaled by 3, up 4. So let's put in an x-axis and a y-axis, and we know that if we go right 1 and up 4, let's put in a better x-axis. Well, hopefully it'll be a better x-axis. So right 1, left 1, because it's a plus, right? Left 1 and up 4 means that our vertex should go left 1 and up 4. 1, 2, 3, 4. So our vertex will be there. And it opens down. And so if we go, and it opens down and is scaled by 3. So if we go 1 unit to the right, we should go 3 units down. So 1 unit to the right, 1, 2, 3 down. 1 unit to the left, 1, 2, 3 down. So we should be scaled like that, and our parabola should look like that. And luckily we found exactly where our y-intercept is. That's our y-intercept is y equals 3. Okay, so we know where the vertex is. Right? We went 1 unit left and 4 units up, so that's at x equals minus 1, comma 4. Our central axis goes through our vertex, so x equals minus 1. Through here is our central axis. Range, well, it opens down, so we want no numbers, no y values bigger than the y value at the vertex, so y less than or equal to 4 is our range. We found the y-intercept because we were a little bit lucky. That's y equals 3. And then the last thing we need to do is find the x-intercepts. And there's 2 of them, and we can't read them off from the graph right now. So put a little question mark, but there's one there, and there's one there. Now what are they? Well, go back to the formula. Set y equal to 0, solve for x. So we get 0 equals minus 3, x plus 1 squared plus 4. So we'll take the part that's got the minus sign and move that over to the other side of the equation, and it shows up as a plus. Divide by the 3 to isolate our squared thing. And now take the square root of both sides. Plus or minus, of course, because it's square root. Now square root of 4 is 2. Square root of 3 is something. So we'll just write square root of 3. And then finally, subtract a 1 from both sides. And of course we get that minus 1 there, right? Because that's my central axis. X equals minus 1 is the central axis, and we know that our roots, our x-intercepts, have to be the same distance on either side. So 1, this one, is x equals minus 1, that's the central axis, plus 2 over root 3, and the other one is to the left of the central axis, x equals minus 1 minus 2 over root 3. Great, and now we know everything we need to know. So, if we have our parabola in this form, right, constant times the quantity x plus something squared plus another number, then it's not too hard to be able to find out all the stuff that we want to know. What about something like y equals 4x squared plus 20x plus 7? Well, that we need something called completing the square. And remember back in section A7 when we were talking about ways to solve quadratic equations, right? Completing the square was one of the ways to do that, and we didn't see it in A7, we just saw factoring in the quadratic formula. But next video will be on completing the square and how can you find out all the stuff you want to know about a parabola